Today we're going to be looking at a script that I used for being able to pick up 2D objects and throw them around the scene. I had an original script that I was working off of that just allows you to move the object around the scene, and then we just build upon that by adding velocity and a hinge joint. So the behavior that we see with the original script that I was working off of is that you're able to pick up an object that'll follow the mouse around in 2D, but as soon as you let go of the object, it doesn't continue with the mouse. So when you let go, it's just going to drop. And if you move the mouse really fast, it's a little more noticeable. You can see it just kind of doesn't have any velocity applied to it and immediately has gravity start acting on it. So if we move that around, it'll just drop off the screen. What I ended up doing initially was I just took the same script and I calculated the position of the object on one frame, and then the next frame I would pull its position again, and I would just calculate the velocity that was acting on it in those two frames, and then apply that velocity to it after I let go with the mouse. And that allows you to sort of take the object. When you move it around, if you just drop it, of course, it's going to have gravity that acts on it. But if you move it really fast, it'll have some velocity applied to it as soon as you let go. And that's great. But the problem with that is that if you have an object like this, it looks okay. If you have an object like this and you grab it and you move it around, it doesn't look very good because it's flat the whole time. And if you, say, have an angle to it and you move it around, it just stays at that angle the whole time. It just has the position applied to it while the mouse is holding onto it, and then the velocity is only applied after you let go with the mouse. So I took it a little bit further. I saw some recommendations to use hinges, and then I ended up taking this object right here. I did the same sort of a script where it'll move around, but instead of moving around the object, I move around a hinge, and I attach this object to that hinge. It allows you to, when you move it around, it'll sort of teeter back and forth. It's got some rotational velocity on it. If you pick it up by a different point, this is where it makes it a little bit better. It'll change how it acts based off where you pick up that object. So I can pick it up by the corner here, and then I'll swing it around. And then when I let go of it, it'll both apply the mouse velocity, which is great for throwing it back and forth, but also it'll apply the rotational velocity if I just let go. Makes it look a lot more realistic, and it's much more noticeable when you have an object like this. You can pick it up, it'll rotate around. You can swing that object around. And then again, to compare that to the script that we had before, we'll get rid of these square characters here. So to compare it with just these guys here, you can see on the first one, nothing happens, it just sort of drops. Get rid of that. On the second one, it'll have the velocity, and on the third one, you can just pick it up, and if you pick it up on any of these corners here, it's just going to automatically center that object on the mouse. So now going over how I did this, the initial script, this isn't exactly what the original tutorial had. I kind of messed around with it, and it's not very pretty at the moment. But the original script just takes the position of it and tracks it to the mouse. When I had improved upon that, at least for my project, what it did was it calculated the object position, and then it took the previous object position, and it pulled the velocity from there. And then after you let go of it with the mouse, it would apply the velocity to the rigid body. And this also not very pretty. This isn't something that I'm going to be using in my project, so I just ended up throwing something together. For this one here, I try to make it as nice looking as I can so that I can post it and have it available for you guys to download and use in your projects if you decide that you want to. Essentially what it is that I have the object that you are going to act upon. You'll attach this script to. You'll be able to click on that object anywhere on the 2D collider or mesh collider, whatever it is that you attach to it, although it'll act on it in 2D space. You'll be able to click on it, it'll follow the mouse around, but only to where the hinge is attached. So the hinge will track to where the mouse is, then the object will be pulled to where the hinge is and sort of spin around that. And then at the start of the script, you can see here I'm just attaching the rigid body that's attached to our game object that we're putting the script on, and it's finding in the scene an object named hinge point. And you have to have this object in your scene or the script isn't going to work. And how I have that hinge point set up in my project, pull this over here, is I just have a regular game object here. It has a static rigid body on it, has the MouseDrag script, which is not really necessary. I should probably pull that off there. Has the hinge joint 2D there. This one right here is just a regular hinge joint. This isn't something that I made. This is something that you can put on by going to physics, 2D, and attaching a hinge joint, or just add component here. I have it set up to just auto configure the connected anchor. And so if you put that in your scene, name it hinge joint. Whatever object you put in your scene that then has this script attached to it will show it off here by just duplicating one of these objects. This is one that has it. Duplicate that, move it around. You'll be able to act on multiple objects. See, duplicate the wrong one there. So I want this one. So that one right there. Okay, so then let's go back to the script here. So again, this is how it attaches the hinge point to it. When the mouse is over the object and you click on it, it's going to execute this function. This is just on mouse down. It's going to just assign to the hinge, it's going to assign the current mouse position. So the hinge snaps to where the mouse is on the screen. And then once you've done that, it's going to be able to attach the rigid body that you're clicking on to the hinge. So though the hinge is moved, you're not moving the rigid body with the mouse, you're moving it with the hinge. And then if we go down to here to fixed update, we've set move true here. While move is true down here, it's going to execute these functions. And this again is just doing the same thing that we did up here. This is going to track the mouse position with the hinge. And then down here, what it's going to do is it's going to take and this is for calculating the velocity, it's going to take the object position, the current object position, it's going to subtract the previous object position, which is just saved as last position, and then it's going to divide the time.fixed delta time, which is the amount of time that's elapsed between this previous calculation. And then after this is calculated, it's going to take the position and save it as last position to be used the next time around when we calculate the velocity again. And then when we let go with the mouse, what we're going to do is we're going to disconnect the rigid body, the object that we're clicking on. We're going to then turn on auto configure connected anchor. What this is going to do is the next time that you click on a rigid body, it's going to automatically set the hinge distance to that rigid body, so it'll snap to it instead of having a weird distance and giving us kind of some strange behavior that we don't want. And then it's going to disable that joint so we don't have it sitting active in the scene. And then we'll just set move to false, so we're not continuing these calculations. And it will apply the current velocity of it, which is we're just saving as rb.velocity. That's just what's going to be left over from our hinge spinning the object around. And then we're going to apply the velocity that we were calculating right here, and this will just make it look a little bit more realistic.